Here we have a log function with base a, and we want to find the derivative of this function. And so the definition of the function y equal to log base a of x is if and only if x is equal to a to the y. And so this is the definition of the function log base a of x. And so we'll start with this equation right here, x equal to a to the y. A is just some real positive number. And so we have x equal to a to the y, and now we take the natural log of both sides, and we get ln of x is equal to ln of a to the y. And then by the power rule, we can move the y, the exponent y, and place it in front of the ln. And then divide both sides by ln of a. Then we get y to be ln of x, dividing by ln of a. And therefore y is log base a of x. And therefore we have log base a of x is the same as ln of x, dividing by ln of a, the natural log of a, which we can rewrite as 1 over ln of a times ln of x. And so log base a of x is the same as 1 over ln of a times ln of x. And now we can take the derivative. And so the derivative of log base a of x is equal to the derivative of 1 over the natural log of a. Again, a is just some real number, some constant, times ln of x. And so this is equal 1 over ln of a is a constant, so we can move it and place it in front of the derivative here. But the derivative of ln of x is 1 over x. So we have 1 over ln a, and then times 1 over x. And so this becomes 1 over ln of a, and then times x. And then instead of which is x, if we have a function u, where u would be some expression of x, or some function of x, then by the chain rule, this would be this. The u right here, and then times du dx. And then sometimes this is written like this also. And that's the derivative of log base a of x. So a summary. Before we have the derivative of ln of x, this is just 1 over x. And then now we have these results. So if it's log, this is the same as log base e. We could also write this like this, log base e. And so now let's do some examples. So here we have the function log of base 4 of 2x plus 5, and we want to find the derivative. And therefore, if we have log of base 8 of x, then it's just 1 over ln a of x. But since we have the expression 2x plus 5 here, then we have to use the chain rule. So it would be right here, so it would be 1 over ln 4, and then times the expression 2x plus 5, which is the u, and then we have to multiply by the derivative of the expression 2x plus 5. So that's how we would use the chain rule. And then this becomes the derivative of 2x is just 2. And so the answer will write like this. And here we have the function log of base 5 of 14 minus x squared minus x, and then square. And we want to find the derivative. So first, let's rewrite this. This is the same as, since we have that exponent 2 right here, then we can apply the power rule here. So the 2, we can move it to the front, move it and then place it in front of the log. And then now we can find the derivative. And again, the chain rule is this. And so here we would let u be 14 minus x. So the derivative would be 1 over ln of 5, since the base is 5, and then times the expression 14 minus x. And then we have the 2, we can place it in the front here. And then times the derivative of the 14 minus x. And the derivative of 14 minus x is just negative 1. Negative 1. And so the final answer, we have negative 2. 2 times 1 times negative 1 is negative 2. Dividing by ln 5 times 14 minus x. And here we have the function log base 3 of the square root of x to the third minus 15. And so first let's rewrite this so we can get, and then we'll find the derivative. So this is the same as that's x to the third minus 15. And then square root is the same as rational exponent of 1/2. And then here we have log of an expression and then followed by the exponent. Then we can move the exponent and place it in front of the log. And that's the power rule. And then now we can find the derivative here. So once again, the chain rule was this. So we get 1/2 and times, it'd be 1 over ln a, which is the base number, so it'd be 1 over ln 3. And then times the expression x. So u would be the x to the third minus 15, and then times the derivative of x to the third minus 15. The derivative of x minus x to the third minus 15 will be 3x squared. And so the answer would be on the bottom here we get a 2, and then the top we get 3x squared. And this is the answer.